Mosquitoes go viral when they smell this. So, what is it? Perhaps your blood is too sweet to feed on. Oh, really? Be ready to get fed more. Dengue, the mosquitoes-borne disease, is now endemic nearly worldwide. Southeast Asia, Americas, and Western Pacific regions represent the main global disease burden. Dengue disease will not spread without a vector, in this case, it's mosquitoes. Eliminating mosquitoes, or avoiding their bites, is the key answer to reduce dengue burden worldwide. So, what factors seem to draw mosquitoes to locate their next meal? Mosquitoes are attracted to heat-trapping carbon dioxide and dark hue, we were told. So, no dark theme wear, and minimal outdoor activities during warm night, becomes a routine health advice in dengue prevention. What if your idea of mosquitoes attracted to heat were wrong? So, what exactly trigger mosquitoes to go viral and bite one, but spare others? I like to joke that it's because their blood is sweeter to feed on. It turned out that the joke is real. It's not the heat, but the sweet smell that draw mosquitoes to their next meals. Stay tuned to find out how some disease-causing viruses make people smell extra tasty or fruity to mosquitoes. The scientific experiments revealed that infection makes the host smell sweeter and more attractive to mosquito bites. This is indeed a clever tactic in evolution that makes viruses to increase their chances of survival by fast migration before being defeated by the host's immune defense. Ironically, the science has turned down the old saying that mosquitoes are attracted to carbon dioxide. The experiments led by the scientists from China demonstrated that mosquito-borne viruses like flaviviruses have the ability to make the host more appealing to mosquitoes. This fascinating experiment was of course a mouse study primarily, but human subjects were later recruited to cross-check the findings. The experimental setup went this way. A bunch of mosquitoes were kept in a central chamber. The mice, infected with the flavivirus, was put on right, whereas those uninfected were kept on left chamber. The experimental result shows that, instead of 50-50 mosquito split pattern, 70-30 was seen, in which 70% of mosquitoes were attracted to right chamber, with infected mice. To prove that the mosquitoes weren't just being attracted to higher body temperatures, the research team, in separate experimental setup, inoculate the non-infected mice with a potent fever inducer, the lipopolysaccharide. The mosquitoes didn't seem to care. They were equally attracted to control mice on the left, and febrile but virus-free mice on the right. The team also found that uninfected sick mice actually generate less carbon dioxide than uninfected mice. It turns out that the specific smell, not carbon dioxide, drives the bloodsuckers. To test this, the researchers put a filter between the mice and the mosquitoes to block all odorant molecules. To the surprise, the mosquitoes now had no preference between sick and non-sick mice. More than 10 volatile compounds that generate smell were then identified by researchers in both sick and healthy mice. Of these, acetophenone stood out clearly as the aroma that triggers the mosquitoes to bite. Acetophenone has a sweet pungent taste and distinctive fruity smell. It's a naturally occurring fragrance ingredient used to impart scents in perfume or food flavorings. The perfumes created have a sweet base notes, and the smell described as fruity, almond, or jasmine. Perhaps it's not a good idea to wear such fruity perfumes in dengue countries. Interestingly, dengue viruses seem to promote the acetophenone producing skin flora by inhibiting an immune defense substance called realm alpha. Subsequently, the researchers were able to show that, in humans, mosquitoes were attracted to the odor of dengue-infected patients. Compared to controls, there is a significant higher acetophenone level noted on the skin surface of infected patients. The fact that dengue viruses make their hosts smell attractive to mosquitoes is a scientific masterpiece of survival and evolution. These intriguing scientific findings explain the natural ability of dengue viruses to bring mosquitoes to humans closer and closer, establishing a chain of infection that is difficult to break. In the fight of dengue, we have various methods, from simple mosquito net and spray, to highly sophisticated, genetically engineered death mosquitoes that reproduce and give male carrier, but dead female offspring. To fight dengue more efficiently, scientists need to find a way to break the ability of dengue viruses to make their hosts smell attractive. Until then, pray for the best for for dengue-infected patients, in terms of fast recovery, without hemorrhagic dengue fever.